Hi, my name is Rahul Drissel and I work as an AWS Solution Architect and a Udemy instructor. You can check out my Udemy courses in the link below in the description. In this video, we're going to look at AWS API Gateway, which is one of the most important serverless services from AWS, especially from the app modernization and microservice architecture perspective. In this video, we're going to look at top 10 capabilities of AWS API Gateway and how you can leverage them in your serverless architecture. So now let's go ahead and take a look at these capabilities. So what is an Amazon API Gateway? It's an AWS service used for creating, publishing, maintaining, monitoring, and securing REST, HTTP, and WebSocket APIs at any scale. Now let's take a look at the example here. So you have the Amazon API Gateway through which you can create, publish, maintain, and monitor any REST APIs. So once you create these REST APIs, these can be consumed and invoked by any of the interfaces shown here. So you could have a web and mobile application, IoT device, connected users, etc. Now these interfaces can make an API request. Then Amazon API Gateway will authenticate and authorize those APIs. It can invoke any of the services defined here. So it could be either an AWS Lambda, Amazon EC2, Kinesis, Amazon DynamoDB, or it could be any publicly accessible HTTP endpoint. And it can also connect privately to your data center. Okay, that's a high-level overview of what an Amazon API Gateway is. One of the most common architectures where Amazon API Gateway is used is RESTful microservices. So all the product development that you do these days is using the microservice-based architecture. So here, how does it fit into the microservice-based architecture? So you have an app, whether a web or mobile app, will make a request to this API Gateway. API Gateway will authenticate and authorize that request. And if everything is fine, it will invoke the Lambda function. Then this Lambda function is going to make a call to the backend, retrieve the data, pass it on to either the web or mobile interface. Now let's look at some of the key features of the AWS API Gateway. The first one is the API type. So there are 4 types of APIs. So you have the HTTP API, you have the WebSocket API, you have the REST API, and you have the REST API private. So I'll go to the console and then show you. So I will just go to this API Gateway. Now I'm on the AWS API Gateway console. So you can see there are 4 types of API that we just discussed. The first one is the HTTP API. What is an HTTP API? It builds low latency and cost effective REST API. So if you want to build low latency cost effective REST APIs, then you can use HTTP API. So some of the backends that it support is Lambda and any HTTP backends. So the next type we have is WebSocket API. So if you want to build persistent connection for real-time use cases such as chat application or dashboards which require a persistent connection, then you have to use the WebSocket API. The third one is REST API. So when you want to develop a REST API where you want to gain complete control over request and response along with the API management capabilities, you use the REST API. So the backend it supports is Lambda, HTTP, and AWS service. And then you have the REST API private. Okay, now let's see what this means. So if you can see HTTP API and REST API, they are pretty much same, and I will give you the key difference on when to use the HTTP API and when to use the REST API. So when to use the REST API versus HTTP APIs. So REST APIs support more features than HTTP APIs, while HTTP APIs are designed with minimal features and offered at a lower price. So if you want minimal features and low price, then you use HTTP API. But if you want feature-rich capabilities, then use the REST APIs. So what are the capabilities that REST API has additionally? It supports API keys per client throttling, request validation, WAF integration, and private API endpoint. And we're going to look at all of these in detail. But for now, just assume that if you need to build REST APIs and feature-rich, then you use REST APIs. If you need low cost, low feature REST APIs that you need to build, then use HTTP API. If you need to use persistent connection, then you use the WebSocket API. And then finally, you have the REST API private. There are a lot of industries such as banking and pharma, which have a regulation that you can access the APIs only through a private network. So when you create REST APIs privately, then these APIs will only be accessible from your VPC. So you and I cannot access it through the internet. So those requests will have to be routed to your VPC, say EC2 instance or any other AWS service, and routed via the VPC endpoints through the AWS private link to the API gateway. So for now, we are just going to choose this REST API. So let me just click on build. So the first thing I'm going to do is choose the protocol. So we discussed about REST and WebSocket API. So I'm going to select REST, and then you have to create new API. So here you can use an example API as shown here, the pet store, but I'm going to choose the new API. Now it will ask me the API name. So I will say demo API, and then you can give a description. It's optional. Then you have to choose the endpoint type. So you can see there are three types: regional, edge optimized, and private. So let's take a look through the diagram what this means. So you can see here the API endpoint type. So there are three. We have the edge optimized, the regional, and private. So the first one you can see here, edge optimized. So this is mainly used if you have a global application and you have users across the globe who are going to make requests to your API gateway. Then through the edge optimize, what you can do is here you have the API gateway and you can front end with the Amazon CloudFront. So if you have requests coming in from any part of the globe, they can be routed to the Amazon CloudFront, and then through the AWS network, they will be routed to Amazon API gateway. So this reduces the latency. But if you have an application that is going to be accessed only from a particular region, say India, Japan, Australia, or US, then you can create a regional API gateway, and the users from that region can make a request to this API gateway, and then it can route it to any of the AWS services, whether it's Lambda or endpoints on Amazon EC2, etc. Then the third type of API endpoint is private. So we had discussed that there are some scenarios in banking or pharma where you need to route the request not over the internet but over a private network. So in that case, if there's a request that is routed, it needs to be routed to your VPC first. Then say here you could have an EC2 or any other AWS service. Then this service is going to route it to the VPC endpoint, and then from there it is going to be routed through the AWS private network called as private link onto this Amazon API gateway. This cannot be accessed from the internet. Okay, now we know what are the regional, edge optimized, and private endpoint types. So we're going to select regional for now, and then I'm going to do a create API. And you can see now our demo API has been created, and this is the REST API ID. Okay, now that we have created the AWS API gateway, we have to create resources and methods. So resources, we know as per REST architecture, treats every content as a resource. So these resources can be text files, HTML pages, images, videos, or business data. And then we have the methods. So there are mainly four key methods. We have the get method, which will retrieve information about the REST API resource that you might have created here. Then you have the post, which creates a REST API resource. Then you have the put, which updates the REST API resource. And then you have the delete, which deletes a REST API resource or related component. So now we are going to create a resource, and then we are going to create one method. Okay, now we are going to create a resource. So I'll just click on this action, create resource, and let me call this resource as students. Let's say we're at college and we are trying to retrieve the details related to a student. So the resource path would be /student. So I'll just say create resource. Now you can see the resource has been created here. Okay, now we will create a method. So I'll click on students, click on action, create method, and then there are all the methods that are available. So I'll say get, and I'll click on this. You can see now it's created the method. So now let's look at the next concept called as integration type. Earlier we had discussed about the various integration points for Amazon API Gateway. The first one we had discussed about Lambda. So you can integrate API Gateway with the AWS. So the second type of integration possible is with any publicly accessible HTTP endpoint. So you can integrate Amazon API Gateway with any HTTP endpoint. Then you have the mock. So what mock means is that you will have a type of integration with API Gateway where the request is not sent to the backend. So it is only used for testing purpose. Then you have AWS services. So you can basically integrate with any other AWS service, whether it's Kinesis, DynamoDB, EC2. So then you have the VPC link. So VPC link is usually used. So when you are trying to connect API gateway to a resource within your own VPC, and we'll take a look at it in a little bit. But for now, it is used for connecting private resource inside a VPC. Okay, now if I go to the console and if you see the integration type, these are all the types you have. So you have the Lambda function, we already discussed, it integrates with the Lambda function. Then you have the HTTP, it integrates with any existing HTTP endpoint. Then you have the mock, it returns a response purely on API gateway, mappings and transformation. So it doesn't go to the backend, it's just used for testing purpose. Then you can integrate it with any AWS service, And then finally, you have the VPC link. If you want to route a request to any AWS service within the VPC, then you use the VPC link. And then you can also use Lambda proxy integration. So API Gateway can also do some kind of a transformation if there are any incoming requests. But when you use Lambda proxy integration, what it will do is it will pass the request as it is to Lambda function, and it will not do any kind of transformation. So what we are going to do in our case, we are going to select this Lambda function, and then a region will remain the same, US East. And I've already created a Lambda function, API Gateway Overview. It's a very simple Lambda function. Basically, it just returns status code 200 and hello from Lambda. So I'm just going to copy this name of this Lambda function, and I will go here and I will just paste here the name of the Lambda function, and I will do a save. And then it says you are about to give API Gateway permission to invoke Lambda function, and that's fine. So I'll do OK. So now before we test the API, you can see there is a method request, integration response, and method response. And then we have the Lambda, which we just provided the name of API Gateway Overview. Once the client makes a request, and if I go to method request, you can see it provides information about methods, authorization settings, and parameters it can receive. So you can configure what kind of authorization you will use and what are the parameters that will be allowed. So the first you can see authorization, and here you can see AWS IAM. We will talk about various authorization methods a little bit later. Then you have request validator. What do you want to validate? Whether we want to validate body, query string parameters and headers, and then whether you require API key. So we're going to take a look at that in a little bit, and then you can define other parameters as well. Now, if you look at the integration request provides information about the target backend that this method will call and whether the incoming request data should be modified. So the first, you define what integration type you're looking at, and we discussed all these, whether it's Lambda function, HTTP, mock, etc. So once you have defined what are the changes that need to be made to the incoming request data based on what is expected at the backend, you can go to this mapping template and make those changes. So if you see the AWS documentation, it says that you can use a mapping template using the velocity template language. You can modify the incoming request based on what is expected at the backend. Similarly, once you have the response coming back from the backend, then you can use integration response based on what is expected by the client. Okay, now with that, let's just test it out. So I'll just do a test, and I will do test. You can see I've got a response body. So it says status code 200 body hello from Lambda, and this is what we had in our Lambda that we had defined earlier and configured it with the API Gateway. Now once we have tested it out locally, we will need to deploy this API. Once you have created the API, then you need to do the deployment, and then there is a concept called as stages. So what stages means is, it's basically similar to when you are deploying a web application. So you'll deploy it to dev, prod, beta. In the API Gateway terms, we call it as stages. So one important tip you need to remember is every time you update an API, any change you made, whether to routes, method, integration, you have to redeploy API to an existing stage or a new stage, otherwise it will not work. So let's do that. So now I have this student resource and method get. So I'll click on this action. I will set deploy API, and then I will set deployment stage. So you can define new stage because we don't have any stage. So let me say dev and then do a deploy. Okay, now you can see I have the stages here. So I have the dev stage, and if I click on this and click on that get method, I will have an invoke URL. So I can just copy this invoke URL, and if I run it, I should get the same response that we have in the Lambda function. You can see here status code 200 and body hello from Lambda. Now you can see the URL that we got, invocation URL that we got, is in this format. So you have the HTTPS, then you have the REST API ID, and if I can just copy it from here, this URL, and I will just paste it here, and you can see the format. So you have the HTTPS, then you have the REST API ID. So this is our REST API ID. So you can see here our REST API ID, and then we have the execute API. So we have the execute API, then you have the region US East 1 in our case, and then you have the stage name. So in our case, we had the stage as dev, and then we have our resource. So this is the format you will get the invocation API. Next, we're going to discuss about usage plans and API keys. So a lot of times you might want to differentiate between basic and premium customers. Based on whether it's a basic or premium customer, you can set some throttling, burst, or quota limit for each of the customers. So let's take a look. So here you can see I've created a basic usage plan, and it has an ID and name, and then you can define the rate. So how many requests it can make per second. You can define the burst, and you can also define the quota. So whether it can make 50 requests per month or 5,000 requests per month. So you can define these three parameters, rate, burst, and quota, and then define the usage plan. So typically, if it's a basic plan, all those limits would be much lower, and if it's a premium customer, then those limits would be much higher. Next, we have the API keys. So these are basically alphanumeric strings that API Gateway uses to identify an app developer. So once an app developer makes a request, he uses this alphanumeric string or the API keys to identify itself. So let's take a look. So I'll just click on the demo API that we have created. And if I scroll down below the usage plan, we have the API keys. So I've already created one API key demo, and you can see here, if I click on this show, it will show me the alphanumeric string and API key, and which can then be tagged to the usage plan. In this lecture, we're going to learn about various authentication and authorization methods that you can use within an AWS API Gateway to authenticate and authorize the requests coming to an API Gateway. So there are basically three approaches that you can take. The first one is using the AWS IAM service. Second one, you can use the Cognito user pools. And the third one is using the Lambda Authorizer. Now let's take a look at in what scenario you will use what kind of an approach. So you'll use AWS IAM in a scenario where the request is coming from internal AWS services. So it can be an AWS service within the same account, or it could be a cross account access. In this scenario, you use AWS IAM for authentication, and authorization is done through the IAM policy attached to that IAM role. Now let's take a look. Say you have a client here. It can be any AWS service such as EC2 within or cross account. Now this client, an AWS service, makes a REST API call using the SigV4 capability to API Gateway. The API Gateway has an integration with the IAM service. So it will evaluate the IAM role attached to that service and the IAM policy attached. So it will validate the IAM role and policy with this AWS IAM service. And if everything works okay, then it is going to enable access to the backend. If the request is coming from the same AWS account, then you can just use the IAM role and attached policy. But if it's a cross account access, then you have to additionally use a resource policy within the AWS API Gateway. So let's take a look. So I am on the AWS console, and this is our REST API that we had created. So now say I want to authenticate and authorize using the IAM policy, then I'll just click on this method request, and you can see authorization here. So I'll click on this and I can select AWS IAM. Now say if there's a cross account access, then what I need to do is I need to go on this left panel, click on resource policy, and you can see it gives me various options. And here, if I select the AWS account list, I can define the AWS accounts which will have access to this API gateway. Similarly, I can define the IP range deny list and source VPC allow list. So we'll have to use a combination of IAM and resource policy for cross account access. Now the second scenario is using Cognito user pool. So this is the right fit use case for this is when you have external users for your web or mobile apps. And in this method, the authentication is done through Cognito user pool and authorization through the API gateway methods. So now let's take a look at this diagram. You have a client who's trying to make a REST API call via the API gateway. So what the client would first do is it will make a request to this Cognito user pool, and Cognito user pool should already have the identity for this client. So once he makes a request, it will authenticate the request, and if all goes well, it will provide it with a token. So this client would now have a token. Now this client is going to make a REST API call along with the token that has been provided by the Cognito user pool, and it will make that request to the API gateway. So once the request comes to API gateway, the API gateway already has an integration with the Cognito user pool. So it will validate this token provided by the client with the Cognito user pool. And if the token is validated, then it will allow the request to come to the backend. So this is the second way in which you can authenticate and authorize using the AWS API Gateway. We'll take a look at the console in a little bit. But first, now let's look at the third approach that we can take. Now the third approach and the most common one is called as Lambda Authorizer. So the use case for this is mainly when you want to authenticate your request using the third-party identity provider. So here the authentication would be done externally by this third-party identity provider, and authorization would be done by the Lambda function. So now let's take a look at the diagram. So here you have the client which is going to make a request to this third-party identity provider for authentication. Once it sends the request, and if it is validated, the third-party identity provider is going to pass on a bearer token or some parameters to this client. So once this client gets the bearer token, it is going to make an API request to this API gateway. Then this API gateway is going to pass on this token or request parameter along with context to the Lambda function. This Lambda function, where you will have to write a little bit of code, is going to validate this token or request parameter with this third-party identity provider. And if the request is validated, then it is going to pass on the principal and IAM policy back to this API gateway. And this request from the client is allowed to access the backend. And for future use, this policy is evaluated in the cache attached to this API gateway. And if the request is denied, then it goes and sends a 403 back to the client. So this is how you can utilize the Lambda Authorizer for authentication and authorization. Now let's take a quick look at the console. So now I'm on the console. So on the left, you can see Authorizer. So I'll just click on this Authorizer and I'll just click on Create New Authorizer. And then you have to give the name of the authorizer. So it can be two types, as we saw, the Lambda Authorizer or the Cognito. If you look at the Lambda Authorizer, then what you have to do is you have to write the name of the Lambda function. So because you are using a Lambda function here, this is what you will have to provide here. Then you provide the Lambda invoker role, and then you provide the Lambda event payload. So whether it's a token or it's a parameter request. So there can be two types. Then you provide the token source and token validation. Then you can also enable the caching of the policy. Then if I look at the Cognito, so you can see here, Cognito, you have to provide the details of the Cognito user pool, and you also have to provide the details of the token source. You'll have to create the Cognito user pool in the AWS Cognito service to utilize and use this service. Now in this lecture, we're going to learn about API integration and private APIs. So this is a fairly advanced concept, but nonetheless, it is used a lot in the enterprise setting. So in one of the previous lectures, we had learned about API endpoint types private, where we said that this Amazon API gateway is only accessible from a VPC and not directly from the internet. So this is the same scenario. Now let's take a look at this diagram. Here you can see you have the Amazon API gateway. One thing you need to remember about Amazon API gateway is that it is not deployed in the customer VPC. It has its own API gateway VPC, very similar to the Lambda function. So now say I want to access this Amazon API gateway, which is deployed in this API gateway VPC. I have two options. One is that I can directly access through the internet, and which is pretty straightforward. I will get the invoke URL and I will be able to access this. But in this scenario, we do not want that this is accessible directly from the internet due to a lot of regulations in banking, pharma, and some of the other industries. So what they want is that this is accessible only from their customer VPC. So now let's see how this works. So you have a client here. It can be any AWS service such as EC2, Lambda, etc. From here, the request is routed to an interface VPC endpoint, which you have to create within the VPC. So once you create the interface VPC endpoint, it will create an elastic network interface, and all the requests are routed to this ENI. From this ENI, the request will be routed to this Amazon API Gateway on AWS private link, which is an AWS service to route any traffic on AWS private network and not through the internet. So once the request reaches this Amazon API Gateway, then it will authenticate and authorize the REST API call. And if everything works okay, then it is going to allow access to the backend. So in this case, you can see here the customer VPC from the where the request originates is the service consumer here, and Amazon API Gateway VPC is the service provider. Now let's take a look at the next concept, which is the private integration and VPC link. So now say you have routed the request from your VPC to this Amazon API Gateway on a private network VPC link. But now this Amazon API Gateway needs to access, say here you have an RDS database in the private subnet of the customer VPC. So you have the RDS, which is the customer VPC in a private subnet. So how does this Amazon API Gateway access this particular RDS instance in the customer VPC? And we had already discussed that Amazon API Gateway has its own VPC. So what you will need to do is you will need to again create the interface VPC endpoints within this VPC, and then all the traffic that needs to be routed to this RDS will be sent to this elastic network interface that gets created as part of the interface VPC endpoint. And then this traffic would be routed using the private link to this network load balancer that you need to create in case you want to use the private integration approach. So once the request comes to this network load balancer, then it is going to route the traffic to this RDS instance. So all the requests that go from this VPC to the customer VPC are through the AWS private network called as private link. So typically in the API gateway terms, what you need to do is you need to create the network load balancer, and then you will have to use this VPC link for REST APIs to create this configuration. Now let's see through the architecture how this works end to end without exposing any of your services on the public internet. So you have the client, say an EC2 instance in a customer VPC. You create an interface VPC endpoint, and as part of that, some ENIs get created. So the traffic is routed from the client, say EC2, to this ENI, and then through the private link, the requests are sent to Amazon API Gateway, which is in the Amazon API Gateway VPC. Then say this Amazon API Gateway is trying to connect to a backend RDS. So again, you will create the interface VPC endpoints, and this traffic will be routed to the ENI. From ENI, using the VPC link for REST APIs, you can create this connection through the private link, and you will have to create a network load balancer to which all this traffic would be routed from this ENI to this NLB. And then from the NLB, you could route the traffic to this target group that you have within the customer VPC. Let's take a quick look through the console. Okay, I'm on the console. So what I'll do is I'll say create API, and then I will select this REST API private. So we can do a build, and then I select REST and new API, and here choose a friendly name. So I can just give it as private API. You provide the description, and then you have to provide the endpoint type. This was not the case when we were not using the private APIs. So private APIs are only accessible through the VPC endpoints for the Amazon API Gateway. Create VPC endpoints and add resource policy for the API to allow access. You can just click on this link, VPC endpoints, and so you can just provide the name of the VPC endpoint. Then you can select the service, and here you can just search for API, and it should provide you some options. So here you can provide US East 1 execute API, and then you just select this one, and you provide the VPC where you want to get it created, and then you provide the subnets where it should be available, and then you provide the security group, You can also provide the VPC endpoint policy, and then you just create an endpoint. So I just already created an endpoint, but one thing you need to remember is that VPC endpoints are charged per hour. So if you're using VPC endpoints, you might be charged a little bit. You should delete it as soon as you create the VPC endpoint. Okay. And then you can substitute the VPC endpoint here and then just create the API. This is how you can create a private API and do the private integration.